Hello everyone. So in this video, we will be discussing chapter 12 practice questions. So before we start with the practice questions, there are some of the properties that are left trace of a matrix. So trace of a matrix was defined as the sum of the diagonal elements. Now suppose A and B are two n cross n matrices, then these four properties hold. So you should try take any vector A, let it be 2 cross 2, and then take B. So take A, B, C, D, E, F, G, H. Now the first property is trace of A plus B equals to trace A plus trace B. Trace of A is sum of diagonal elements, which is these two terms. So A plus D. Trace of B is E plus H. Okay, so we have this. Now the matrix A plus B would be A plus E, B plus F, C plus G, D plus H. So trace of A plus B would be this thing. So this becomes A plus E plus D plus H, which is equals to trace A plus trace B. This is A plus D plus E plus H. So the first property is satisfied. Now second, so if this is A, okay, now look at the second property. This was A, B, C, D only. It is A, B, C, D. Now trace C of A. So A is this, C of A would be CA, CB, C square, CD. So trace of CA would be CA plus CD. So this should be equal to C times trace of A. So trace of A is A plus D. So C times A plus D. So same thing. So this is also satisfied. So accordingly, you can see for these two properties. Okay, I'll do for this. You can just verify for the last one. Okay. Now given these values, given these matrices A and B, so AB becomes the first element become AE plus BG, AF plus BH, CE plus DG, CF plus DH. So trace of AB becomes AE plus BG. So the sum of the diagonal elements, these are the diagonal elements, plus CF plus DH. Now BA would be, B is E F G H times matrix A, which is A C B D. So this becomes EA plus FC. Second element would become EB plus FD. Then GA plus HC. Then GB plus HD. Now the trace of BA would be sum of the diagonals. So this plus this. This is EA plus FC plus GB plus HD. So you will see this and this are equal. So for any given 2 cross 2 matrix, I have shown this, and it is possible for every n cross n matrix. Now we'll do at least 2-3 questions from chapter 12 which I think are important. So just try to complete chapter 12 before you start doing these questions. Okay. Now moving to our first question. So given a Leontief model, so we have studied what the Leontief model is. What is the interpretation of the condition that AII equals to 0 for all I? So what was AII? Okay, just try to solve it on your own, then I'll explain. Okay, AII was, this is the input required, the first subscript is the input required to produce 1 unit of, okay, so before that AIJ was, this is not visible, okay, AIJ was the number of units of I which is required as an input to produce 1 unit of J, and AII would mean number of units of I required to produce 1 unit of I. So suppose when AII equals to 0, this means to produce the same good we don't require any input from the same good itself. Okay, suppose you are talking about agricultural output, then to produce 1 unit of agriculture output we require 0 unit of agriculture output. This is what AII means. Okay, coming to the second part, what is the interpretation of the sum AI1 plus AI2 till AIN? Okay, firstly, what is AI1? This means the number of units of good I required as an input to produce 1 unit of first good. Then AI2 means the number of unit of good I required as an input to produce 1 unit of good 2. Similarly for AIN. So the sum would mean to produce 1 unit of good 1, 1 unit of good 2 and 1 unit of good n. The total input required of good I is this sum. I'll repeat again. To produce 1 unit of good 1, 1 unit of good 2, 1 unit of good n, the total input required of good I would be this sum. Okay, now moving to the next part. What is the interpretation of the input coefficients A1j, A2j, ANJ? So A1j means the number of units of good 1 which is required to produce 1 unit of good j. A2j means the number of units of good 2 which is required as an input to produce 1 unit of j. And similarly for ANJ. This interpretation is important. Can you give an interpretation to the sum AIJ plus A2j plus ANJ? Okay. So this we have already discussed what these coefficients mean. Now this suggests that how many units, so this is A1j is how many units of good 1 is required to produce 1 unit of good j. So this sum tells how many units of other goods are required in total to produce 1 unit of j. Okay, I hope this was clear. Now moving to the second question. These are from the book itself. Sorry. So just read the question. A firm produces the non-negative output quantities. So these are the non-negative output quantities Z1, Z2, Zn of n different goods using as inputs the non-negative quantities x1, x2 till xn. So they are producing Z1, Z2, Z2, Zn are the output quantities and x1, x2 is the input of the same n goods. Now for each good I, define yi equals to zi minus xi as the net output. Yi minus zi is net output. So xi is total output, zi is total output, xi is input required of good I, and let pi be the price of good I. Let p equals to this vector, x equals to this, x is the input vector, and y is the net output vector, and z is the output vector. Now they have asked us to calculate the firm's revenue and its cost. So the firm revenue would be the output price times output vector. So this would be a dot product. So P1, P2 till Pn, dot product Z1, Z2 till Zn. So this becomes P1 Z1 plus P2 Z2 plus till goes on Pn Zn. So this is the total revenue that the firm would get. Now if we are discussing about the cost is, so for a firm the cost would be the input times the price. So the cost would be P dot X, which is P1 X1 plus P2 X2 plus Pn Xn. So this is the cost. Okay, we have done this. Show that the firm's profit is given by the scalar product P dot Y. Now we have already found the, so profit is total revenue minus total cost. So we found total revenue, which was P dot Z, and total cost was P dot X. And on simplifying, this was P1 Z1 plus P2 Z2 till Pn Zn minus P1 X1 plus P2 X2 till Pn Xn. So this can be written as P1 Z1 minus X1 plus P2 Z2 minus X2 plus Pn Zn minus Xn. And this is nothing but, this can be further written as P1 into Y1 plus P2 into Y2, because Yi was Zi minus Xi. This was given in the question. Plus till Pn Yn. So we know this equals P dot Y. These are the vectors. Now what if P dot Y is negative? So this would mean that the firm is incurring losses. So if this comes out to be less than 0, this would suggest that the firm is incurring losses. Okay, now moving on to the next question, the last question. Find all the matrices B that commute with A. Okay, so I'm specifically doing this question because you should know the meaning of commute. With A, the A vector is this, in the sense that BA equals to AB. So the commutation property that A into B equals to B into A. So we need to find the vector B. So we have A equals to 1, 2, 2, 3, and let B equals to A, B, C, D. Now, so this is 2 cross 2. This is also 2 cross 2. Since if you want to define AB and BA both, so B should be 2 cross 2. You should know this. Now, the value of AB is A plus 2C. The first element is. Second element is B plus 2D. The third element is 2A plus 3C. The last element is 2B plus 3D. So this is the value of AB. Now value of BA. So this is D times the vector A, and we know in general AB is not equal to BA, but in this question they have specifically mentioned this. Okay, so BA is A plus 2B, then 2A plus 3B, then C plus 2D, then 2C plus 3D. Okay, looking at these first two elements, what we have is this and this. So A plus 2C equals to A plus 2B. A cancels out, so C equals to B. So the B matrix, suppose this is C, so this also becomes C. Okay, now looking at this and this, we have B plus 2D equals to 2A plus 3B. Okay, we cannot further simplify this, so this becomes, we can further simplify this, 2 times D minus A equals to 2B, so D minus A equals to B. And we know since this is equals to C only, so D becomes A plus C. So this becomes A plus C. So basically, and if you will solve the other things, these two as well, you will get the same result. So what we have is the B vector, B matrix eventually becomes A, C, C, A plus C. So if you have a vector of this form, this would commute with A such that AB equals to BA. Okay, so in the next video, I'll start with chapter 13. Thank you.